Hello and welcome to week 14, lesson 1, where we're going to take a look at parallel and perpendicular lines. By the end of the lesson, I'm hoping that you'll be able to determine whether lines are parallel or perpendicular by looking at their slopes. So what are parallel and perpendicular lines? Well, we've been dealing with lines for a little while. I'm showing you a few examples here of lines that you may have seen. We have lines that have increasing or positive slopes, like the blue one on the first one here. We also have lines with decreasing and negative slopes, like the red one here on the first one. We also have horizontal lines. We have vertical lines, not shown here. What we're looking at today is whether lines intersect. All three of these do intersect or not intersect. If they don't intersect, those are parallel. We're also looking at what type of angle is formed when the two lines do intersect. So like you can see here in the second one, these two lines intersect and form an angle right here. They also form an angle right here. Now, measuring the angles is something that we're going to do in geometry. So what are we going to do in algebra? Well, we're going to look at, well, first of all, whether they intersect or not. If they don't intersect, they're parallel or perpendicular. Perpendicular lines make a 90-degree angle. Like I said, if we don't know how to find those measures right now, what can we do? Well, we can take a look at their equations to figure this out. So let's take a look at an example here. We're going to write the equations of two lines. So line A and line B by using slope-intercept form. So y equals mx plus b. So line A, the slope, we can just count. Let's find a nice point there. It crosses the grid line right there at 2. I'm going to go up 3, right 1. So up 3, right 1. That gives me a slope of 3. The y-intercept is positive 2. So the equation is y equals 3x plus 2. Now let's take a look at the red line B. Slope is, find a good point, up 3 over 1. So that would be the slope of 3. Then we can write the equation y equals 3x. And where does it cross the y-axis? At negative 5. So now let's look at their two equations. You should see some similarities and also some differences. Hopefully you see that the parallel lines have the same slope, but they have different y-intercepts. And that's true for every parallel line. All right, so we're going to now just give you two equations. Determine whether the two lines are parallel to each other or not. So we need to look at their slopes. So the first one has a slope of 3/5. The second one has a slope of 4/5. Because they're different, these lines are not parallel. If the slopes are different in any way, they are not parallel. It means that they will intersect somewhere on the graph. Now, it's not always going to be that easy. That previous example, I gave you the two equations in slope-intercept form. What happens if they're not? So this first equation here, the slope is 3/5. That's an easy one. The second one, a lot of people want to say the slope is -3. It's not. This is in standard form. We've done this before. We need to solve this for y. So what do? We add 3x to both sides. So it becomes 5y equals positive 3x plus 12. Then divide by 5. And we rewrite the equation y equals 3x over 5, or 3/5 x, plus 12 over 5. Now what's the slope? It's 3 over 5. And look, the two slopes are the same, and the y-intercepts are different. So -4 for the first one, 12 over 5 for the second one. Therefore, these lines are parallel. What about perpendicular lines? They don't have the same slope. If they did, they'd be parallel, right? But these are not parallel. They intersect. So let's write the two equations again. So the slope is down 4. So you can start here, go down 1, 2, 3, 4. And then right 3, that's positive 3. So that's the slope of -4/3. So if we write the equation, that's y equals -4/3 x plus 2, which is where it crosses the y-axis. For the red line, or line B, let's find the slope again. So it's going to be up 1, 2, 3, right 1, 2, 3, 4. So my slope is 3/4. Plugging that in, I get y equals 3/4 x plus -5 or -5. Now let's look at those two slopes. Those are not the same, obviously. One of them is positive and one of them is negative. Line B was a positive slope. Line A was a negative slope. They also look like the fractions were flipped. Okay? And that's the two things that you need to have perpendicular lines. Slopes of perpendicular lines have the opposite signs and are reciprocals, or flipped fractions. All right, so let's take a look. What if the slopes of the lines have opposite signs but are not reciprocals? So here's an example. Pause it real quick. Graph those two lines. Do they form a right angle? Hopefully you paused it and you tried that on graph paper and you graph those two lines and you see line A, or the blue line, and the red line. That does not make a 90-degree angle. The slopes are opposite. One's -1/5 and the other one's +1/5, but they're not reciprocals. Therefore, these are not perpendicular. Another example, what if their slopes are reciprocals but not opposite? There's an example there. Again, pause. Try graphing those two. You can see that they do intersect because the slopes are different, but they don't make a 90-degree angle, right? The lines are not perpendicular. They have to be both opposite and reciprocal. All right, so another way of looking at this is, to be perpendicular, lines must have slopes with opposite signs, reciprocal fractions, such as these two right here. So 3/5 x plus 4 is positive 3/5, and negative 5/3 x. So I flip 3/5 to make 5/3, and it's the opposite sign of what I had. Those are perpendicular. Now, there's another way you can check it. Two lines are perpendicular if the product of their slopes equals -1. So if I multiply the two slopes together, if they equal -1, you can guarantee that those two lines are perpendicular. So let's take a look. Y equals 5x plus 3, and y equals -1/5 x minus 6. So the slopes are 5 and -1/5. If I do 5 times -1/5, I get -5/5, which equals -1. Therefore, these lines are perpendicular. So let's take a look at this one. Determine if the two lines are parallel, perpendicular, or neither. I would try this one on your own. Pause it. See if you get it right. Okay. So hopefully you paused this and you gave it a shot. You could graph these. You could, if some of you could look at this and see that they're definitely not parallel because the lines or the slopes are different. Or you could do what I just showed you on the previous example and multiply these two together. And you see, you get -2/2, which is -1. These lines are perpendicular. Okay? And that concludes our first lesson. In the next couple lessons, we're going to start writing equations of these parallel and perpendicular lines. So stay tuned.